What if a machine could do more than just read words? What if it could understand the invisible web of meaning that connects them? Well, back in 2018, researchers at Google AI dropped a paper that caused a seismic shift in the world of artificial intelligence. They introduced a model that didn't just skim text, it seemed to genuinely understand it. Its name was BERT, and honestly, it changed pretty much everything. All right, so here's our game plan for this explainer. First, we're going to tackle the huge problem that BERT was built to solve. Then, we'll get into its totally new way of reading and the two clever games it used to learn. After that, we'll see how it just destroyed the existing records. And finally, we'll talk about the incredible legacy it left behind. You know, before 2018, even the smartest AI language models had this one major flaw. They could only read in one direction, from left to right. Now, imagine trying to figure out a really complex sentence, but you can only see it through a tiny little slot, one word at a time, only remembering what came before. That right there was the one-way street problem. And that really gets to the heart of it, right? I mean, how can a machine ever grasp the real meaning of a word like bank? Is it a place you put money, or is it the side of a river? Without knowing what comes after that word, it's just a guess. True understanding requires seeing the whole picture, everything that comes before and after. This slide really lays out the difference. On the left, you've got the old way, the unidirectional models, like the first GPT. They read from left to right, word by word, so each word only has a clue about what happened in the past. But on the right, that's BERT. It's bidirectional. It looks at the entire sentence all at once. This means every single word gets its context from both sides at the same time. That's how it just knows a riverbank is a totally different thing from a savings bank. So, if reading on a one-way street was the problem, the solution had to be a model that could look both ways before crossing. And this is exactly where the team at Google AI had their massive breakthrough. They figured out a way for the model to see the entire sentence, all at once from its deepest core. The key phrase from the paper, the one you gotta know, is deeply bidirectional representations. Let's break that down. Bidirectional is easy. It looks left and right. But that word deeply, that's the real game changer. It means that this two-way analysis isn't just a surface-level trick. It happens at every single layer of the model's neural network. It was baked into the very soul of how this thing learned. Okay, but wait a second. This creates a huge paradox, right? For years, nobody could do this because of one simple problem: cheating. If you're training a model to predict a word in a sentence, but you let it see the whole sentence, well, it can just peek at the answer. It's like taking a fill-in-the-blanks test where the answer key is written right there in the margin. How do you force something to learn if it can always see the solution? And this is where the genius of this paper just really pops. The researchers solved this cheating problem with an incredibly clever workaround. They didn't give BERT a normal test. Instead, they invented two training games that forced it to learn the deep, intricate patterns of language without ever letting it just copy the answer. So, game number one is called the Masked Language Model, or MLM. It's so simple, it's brilliant. You take a sentence and you just hide or mask about 15% of the words. BERT's job is to guess what those missing words are, using only the surrounding words as clues. See, it has to look both left and right to make a good guess. It can't cheat because the answer is literally gone. It's forced to actually learn what words mean in context. The second game is all about understanding the relationships between sentences. This is super important for things like understanding a paragraph or answering a question. The model gets shown two sentences, A and B. Half the time, B is the real next sentence. The other half, it's just some random sentence pulled from somewhere else. BERT just has to say, yep, these two belong together, or no, this makes no sense. This is how it learned about flow, logic, and coherence. Now, these two games are part of this really powerful two-step process. First up is pre-training. This is where BERT plays those games over and over again on a truly massive amount of text. We're talking all of English Wikipedia plus a giant library of books. It's not learning one thing, it's learning the rules of language itself. Then you get to step two, fine-tuning. You take this super smart language expert and show it a small, specialized data set for a task, like figuring out if a movie review is positive or negative. And because it's already an expert, it learns these new skills incredibly fast. The whole idea was conceptually simple, but incredibly powerful. But, the big question was, did it actually work? Well, the results that followed sent absolute shockwaves through the AI research community. BERT didn't just nudge the needle forward. It completely rewrote the leaderboards. 11. That's the number. The day it was released, BERT set new state-of-the-art records on 11 different NLP tasks. We're talking everything from question answering to sentiment analysis. This was not a small step. This was a complete and total domination across the board. And just look at this chart. This shows the GLU benchmark, which is basically a decathlon for language models. The previous best score for models like OpenAI's GPT was sitting at 72.8. BERT came in and scored an 80.5. Let me tell you, an AI research and nearly 8-point jump like that isn't just a step forward. It's a pole vault over the competition. The results on the Stanford question answering dataset, SQUAD for short, were just mind-blowing. Before BERT, the best systems were these complicated ensembles, a bunch of models all working together, and they scored a 91.7. A single BERT model, all by itself, got a 90.9. And when they put a few BERT models together in an ensemble, it shot up to 93.2, even surpassing some metrics for human performance. The authors themselves summed it up perfectly in the paper with this one iconic line. BERT is conceptually simple and empirically powerful. And that is the hallmark of a true scientific breakthrough, isn't it? An idea so elegant it almost seems obvious after the fact, but so powerful it changes an entire field overnight. So that brings us to its legacy. I mean, why are we still talking so much about a paper from 2018? It's because BERT wasn't just another model that topped a leaderboard for a while. It was a fundamental shift in thinking. It changed the very way we approach teaching machines to understand our language. BERT basically rewrote the playbook. Deep, bidirectional architecture, that became the new normal. That two-step dance of pre-training and fine-tuning, that became the go-to workflow for almost everyone. And it cemented the transformer encoder as the architecture for language understanding. It gave the entire world a powerful, open-source starting point that just supercharged AI research for years. When you boil it all down, BERT marks the moment AI truly learned to understand context. Before any AI could write an essay or generate code, it first had to get this. It had to deeply comprehend the relationships between words in a sentence. The ideas that BERT pioneered are the very bedrock that all of today's incredible generative AI tools are built on. That leap from just processing words to actually understanding their meaning and context was absolutely monumental, and BERT was the model that made it happen. It taught machines to understand. And that leaves us with a pretty big question to think about for the future, doesn't it? What will the next great leap teach them?